perché abbiamo già in collegamento Shay Bahramirad, in collegamento da Chicago. Welcome, Shay. I'm sorry for the delay, but our webinar are so interesting that we go over the time we foreseen. So I give the talk, the floor, just a minute to Professor Ghiani, just to give you his welcome to you. And because I have to stay in another call for 5 minutes, so I leave to Emilio to coordinate your talk. Thank you, Emilio.
Okay, thank you, Luigi. Good morning, Shay, and again, thank you for being here, because today in US there is also a holiday, so your presentation is worth double today and for us. And Shay is Vice President of an important distribution company also, or only, as you say, not only delivery energy, but you do many other things with your customers, no? And he was also a director. She was also a director for the smart grid department, I read. And okay, just a few words to introduce you. You can start your presentation.
That sounds good. Good afternoon, and thank you for having me. Let me see if you can see my screen. All right, can you see my screen now?
Yes. Yes, okay.
All right, perfect. Good afternoon, everyone. Well, good morning. It's morning in Chicago and Michigan, where I am. My name is Shay Bahramirad, and as Dr. Ghiani mentioned, I am the Vice President of Engineering and Smart Grid for Commonwealth Edison. I'm honored to speak with you today about the electric grid transformation and how the grid of the future will enable tomorrow's cities to integrate new technologies. Specifically, I'd like to share our future grid vision at ComEd and the efforts we are making to achieve this vision, and how our work will ripple beyond the grid to impact the communities that we serve in Illinois. All right, let me see if I can get this. Let me start by providing a bit of background about ComEd. ComEd is one of the largest electric utilities in the United States. We serve over 4 million electric customers in Northern Illinois, including city of Chicago. We are responsible for the third largest metropolitan area measured by GDP in the country. We do so with more than 6,000 employees and who operate a grid that contains more than 5,000 circuit mile of transmission system and 66,000 circuit miles of primary distribution system. About 52% of our system is overhead and 48% of it is underground. ComEd is the second largest, has the second largest underground network in the United States after Manhattan and in New York. Talking a little about what's changing around us. As the world changes, however, so do the challenges of operating the grid, and electric utilities typically focus on reliability or assuring that there is adequate supply under likely contingencies. But in recent years, there has been more emphasis on the resilience of the power grid. Emerging challenges include the increased risk of physical and cyber terrorism against energy infrastructure, and increased awareness of and operation for public health crisis, just like COVID-19, and greater frequency and impact of major weather events. 2019 is the 5th consecutive year in which 10 or more major weather events and climate disaster events have impacted the United States. Over the last 40 years, the years with 10 and more separate billion dollars disaster events, including 1998, 2008, 2011, 2012, 2015, and 2019. The way we prepare for, and make this a bit bigger for you. The way we prepare for and respond to these challenges need to evolve, and especially considering the disproportionate impact that many of these events have on vulnerable communities. Broadly speaking, reliability focuses on high frequency, low impact events, while resilience deals with low frequency but high impact event. We define, and it's an issue, I say we, and it goes back to we at ComEd, and it's an issue that we as an industry are dealing with right now, that there is not an industry accepted definition and metrics for resiliency, similar to what we have for reliability. But we at ComEd define resilience as the ability to prepare, withstand, and recover and reduce the magnitude of and or the duration of disruptive event, which includes the capability to prepare for, absorb, adapt to, and or rapidly recover from such events. To address these challenges, we have been looking into shifting our approach to the way we produce, distribute, and use energy. Across the United States and the world, we are seeing increased penetration of distributed energy resources, like solar PV, which is requiring utilities to develop the capabilities to better understand them. And as consumers shift to prosumers who are able to generate their own energy, more services must be provided to support things like energy efficiency. Right, let me see if I apologize. It was a bit of my computer froze for a second. So with the integration of renewable and DER, the electric grid is transitioning from one-way to two-way power flow, and this transformation requires enhanced monitoring and control to provide a better understanding of and management of grid condition to fully leverage DER's potential when integrated with the grid. Enhanced level of monitoring and control can be achieved through a communication network utilizing fiber and wireless technologies, providing for transfer of data at higher volume, as well as the speed than current technologies allow. So let me tell you a bit about what we are doing at ComEd. We have had a fiber communication network for our transmission system, but we have started to implement fiber, like that, a combination of fiber and wireless, but mainly fiber. We've been thinking about the future in distribution system and connecting our distribution equipment to that to our fiber system. If you think about it, digital communication technologies are doing on the grid in a way similar to what steel did to enable the modern cities. Before steel, there could be no skyscrapers. Steel bears more weight and has the capability to enable skyscrapers, supporting city infrastructure as we know it today. This is what advanced communication technologies have done to enable the modern grid. Smart meter deployment, which in our case is a 900 megahertz mesh network, has created a digital two-way information and communication network between Comet and our consumers. And advanced sensors such as distribution PMUs and sensors with intelligent measurement platform and low-cost equipment provide detailed insight into grid functions and enabling monitoring. We have had PMUs or phasor measurement units in transmission system, but we have started deploying them in distribution system, trying to connect the data and developing algorithms to develop a state estimation system, which is more accurate than the one that exists in market for transmission system. Another key element in deploying new technologies is to identify and correct emerging issues. We have installed 5,700 square foot state-of-the-art forensics lab in close to Chicago, and success through failure is the theme of the lab. Our aspiration is to evaluate all material failure that create outages and disturbances for our customers. This evaluation will enable how we optimize investments in resilience upfront through what we purchase and the methods by which we train, install, operate, and maintain the grid. The lab enables engineers in my team to perform testing of the equipment and build mock-ups to simulate and anticipate field concerns. The lab is also used to help, engineers in my team to drive, enhance, and refine industry standards. The lab provides capabilities for evaluation of new distribution equipment and for interdepartmental cross-functional training. For example, the space has a dedicated area devoting for improving the performance of lead cable and underground accessories across the distribution system territory. And a new state of art technology capability will allow us to perform deeper dive in-house on material and equipment across our system, including like a 3D, just to give you an example, X-ray capability on mechanical testing of low and medium voltage, high resolution equipment. The last thing I would say about the lab is that it has created an opportunity for us to expand our growing network of collaboration. And if there is anybody in this presentation is interested in collaboration related to the lab or the equipment, I'm happy to connect with you and have a conversation about it. In 2019, we hosted a utility from Australia in the new lab and Japan to collaborate on a systematic process to evaluate root cause failure that may have wide strategic impact on the safety or resilience and reliability of material. Just to tell you a bit about state of analytics, machine learning, and artificial intelligence at Comet, we historically, like, analytics hasn't been part of any utility, but in the past 7-8 years, we have a dedicated team performing advanced analytics. Some of this begins with thinking through the complexity of particular task and making sure that we have the appropriate computing tools to manage it. For example, we use analytics to understand the distribution feeder line, the impact of vegetation and customer outages. These studies are very important, and the computational complexity of these problems is low. We have been looking into the future of the computation and how it needs to evolve in order to accommodate more complex, and that I'm going to talk about it later, and the work that we have been doing in quantum computing. As we embrace new technologies in an increasingly digital age, we must keep up in mind that a major goal of these technologies to mitigate the effect of climate change that we are seeing in our cities. Just to give you a flavor of what's been going on in Chicago, this year we have, in addition to COVID-19, we have experienced a dredge of a number of tornadoes that we haven't seen since 1980s. We have experienced flood in downtown Chicago, and Sears Tower was out of power for a few days. We have experienced number of storms, and earlier in the year and last year, we had days that the difference between the weather in 24 hours, it was more than 100 degrees. So in the morning, it was positive 50, and then at night it was negative 50. So imagine for what happens to almost 50% of the system being exposed to weather. The equipment and the system that is not designed for the 100 degrees change of temperature in a day. What we've been looking into beneficial electrification is that in the US and mainly in Illinois and Chicago, the transportation sector is the second reason of air pollution. And if we want to reduce that carbon footprint and emission and providing the air quality, the first step with the biggest impact would be electrifying transportation sector. And we've been working on a number of projects and R&D projects that they are mainly funded by US Department of Energy with partnership across the board. One thing I've learned through my career is that none of this work is done in isolation, and we have developed a number of fruitful partnerships, as I mentioned. There are over $60 million of grant in the past 5 years provided by US Department of Energy dedicated to different R&D projects, from beneficial electrification and cyber secure platform for fast charging station to different components of microgrid, combination of operation of solar plus storage, and utilizing solar plus storage as a dispatchable generation within a microgrid footprint, as well as working with IEEE and with colleagues across the world, as well as with national labs in the US, to looking into how we can develop, for instance, a calculator for resiliency to measure the impact of resilience in the grid and the financial aspect of it. At the end of the day, that needs to get verified by regulators. As a regulated entity, we need to show that to regulators that the investments for resiliency has a positive net present. So I'll be talking a little bit about Bronzeville microgrid. It's a part of a first utility clustered microgrid in the United States. It's accommodates 7 megawatt of load, and once completed, microgrid will provide a higher level of resilience. That the microgrid provides serves over 1,000 customers. That's a combination of residential, commercial, and industrial customers, and places that public, we call it public good, or they provide they provide services to society, like the Chicago headquarters of police and fire department, the places that we want to have electricity no matter the catastrophic events. One thing I mention here is that this is the microgrid is located in Southside Chicago. This is Illinois Institute of Technology. That's the microgrid that it's been they started building it in like 2008, and they have the capability to go on an islanded mode. And the thought here was to make these two microgrids work together and cluster, and during catastrophic events they completely be separated from the grid and being able to interact and share resources. I can tell you that working on this project for the past 4 years, both the technological side and the design aspect of it, there are two feeders that they are fed from two substations, and synchronizing back to the grid, and the phase angle of the two feeder synchronizing back to two different substations, and solar plus battery, how you want to utilize it as a dispatchable generation, and doing analysis of the observability of the system. The contractual agreement of it has been extremely difficult to what extent those generation is going to be committed to the microgrid, and to what extent the generation that is owned by a third party, not by ComEd, can participate in market functionalities. Then the cost benefit analysis. So it's been a huge effort with a number of, as you can see, partners here to work through it. I talked about that, I mentioned that there are over 14 grants from Department of Energy that has provided over $60 million to ComEd team to work with number of partners, universities, and national labs around the country. And I have listed a number of them here, and I'll be highlighting few of them for you. Shines is a project that addresses availability and variability issues inherent in solar PV, and by utilizing smart inverter for solar and battery storage, and working synergistically with other components within a microgrid. It represents an enabling technology for the widespread sustainable deployment of low-cost, flexible, and integration of a PV plant in grid. The next one that you see from top left is a simple project. It's a project that like $1.5 million is awarded by the DOE for the introduction of voltage and current sensors with enhanced characteristics, and that they provide monitoring in medium voltage distribution system for dynamic protection and control. Once deployed, the sensors will allow detection of events that might otherwise go unnoticed with conventional SCADA technology, and reducing the amount of data traffic that requires the bandwidth. So instead of sending the data back to our control center, the decision making is going to happen within the footprint or at the local area. Especially that's important during storms, that the traffic of the network is high, and that will allow the network to be for all the decisions related to devices to be made in local area. We have developed 3 prototypes and tested in the lab, and they are installed in the field, and we are collecting the data to see how the device actually does what it's supposed to do. The third one is a XFCE EV project that was initiated to develop and deploy cyber secure, extremely fast charging station. We partnered with Virginia Tech, Georgia Tech, Utah State University, Ford Motor, and Onboard Security to develop this platform and testing it in the lab. And then the one other project that I would highlight here is DERMS project. Just to give you an idea about the importance of this project, in December 2017 in Illinois, there was a law passed that would provide very generous incentive for solar installation in our state, and that would translate into increasing the solar in our system by thousands of percentages. What we have been, and then there is a cost associated with integration of solar. And there are places in our territory, in West our territory, in rural area, that that we have had historically about 80 megawatts of wind in that area. And there were a number of requests for 2 megawatts of plant, solar plant connected to that substation. If we wanted to go through the path of upgrading the transformer, then we needed to install a new transformer, and we needed to install increasing the distribution line for miles, and then the cost of upgrade would have gone up to $30 million. Instead, what we did was we installed we are working on an installation of distributed energy resource management system, and by which we can control the output of solar panel, and that would translate into the reduction of whenever the generation of wind and solar is not is out of balance, then we have the capability to curtail the generation. So instead of the interconnection of $30 million, the cost of that is $500,000, and the loss of generation for solar plant is less than 50 hours or so in 1 year. So I'm just giving you these practical examples that how these R&D projects will provide a practical benefit to our customers, to solar plant providers and ComEd customers. It's very important. I don't know about the mix of the audience, but the research, connecting the research with real world, it's been I would say one of the benefit of all these R&D projects that I've mentioned. So as we have been developing technologies to improve reliability, we are seeing results in our metrics. In 2019, we got we were recognized as one of the most improved utilities in terms of reliability in the United States. It's what we have seen with this technology installation is over 70% improvement in reliability since 2012, and as a result of smart grid. With storms and customer experience of 0.72 interruptions on average, which is best on record for us, and 47% improvement compared to when we started investment in EMA. In terms of KD and the number of interruptions, there has been, just to give you an idea, best KD numbers around the world is around 90 minutes. And that's the duration or length of interruptions with storm or with any kind of events. And we have seen about 52% improvement in the duration of outages. So again, it goes back to the impact of all these technologies that we are installing, or we've been working on them. I talked about the importance of resilience and the fact that there is not an industry accepted metrics for resiliency. And what we've been doing is developing 64 different metrics related to improvement of resilience in our microgrid, and utilizing it as a framework for resiliency metrics. It has 3 different components. One is community resilience. The second one is critical infrastructure resilience. And the third one is about energy system resilience. So there's a component of key customers like the Chicago Police Headquarters, airport, FAA, that type of facilities that they provide critical services to consumers. Then there is a component of people, and there's a component of electric grid. The last one related to electric grid is something that we are very familiar with. But the part that is related to the people, it's something that is new to us, and we have been working very closely with a number of economists to develop that. Last thing related to the grid part I would mention is that there are 2 components related to the electric grid. Number one, how many outages we are preventing associated with every single technology. Second, at the end of the day, physics will force for those outages to happen, so how fast you would recover from them. Then it goes back to the situational awareness of the fact that you have for the system in terms of the recovery and how fast you are recovering from the event. Just to give you an idea of, I mentioned about partnership with number of national labs, and that example that I want to give you is the partnership with Lawrence Berkeley National Lab, that we are able to gauge and direct and indirect economic impact of all the metrics that I mentioned in the previous page. As a result of the partnership with National Center for Disaster Preparedness, we are preparing a tabletop exercise focused in Chicago neighborhoods and simulating and modeling the impact on the people side that I talked about, and the broad impacts of different strategies for developing a microgrid in the neighborhood and setting the stage for more complex operation of the grid. We, 4 years ago, we started an initiative called Community of the Future, and we were trying to make a shift in the way that we decide about technologies in neighborhoods. The notion of neighborhood in Chicago is one of the most unique ones around the world. I've lived in 3 continents in several countries, and Chicago is unique in a sense that from one neighborhood to the other, the culture of people is different. And we try to understand that culture, partner with people within the neighborhood to provide the solutions. This place in Southside Chicago is one of the historical African-American neighborhoods in the city of Chicago. And there are a number of non-for-profit organizations that they are very active around electrification, around decarbonization, about climate change. And we try to partner with them to provide, or in some cases, be a catalyst of technology installation. What you see here is that we had a film festival around climate change, and students within that area, there are a number of universities and there are a number of schools, they participated looking into how communities can come together for the impact to mitigate the impact of climate change. So it's one part of our role is to install the technologies and do R&D, and now what you see here is taking the next step to changing the culture of society. What the other picture that you see here, this is a street light that is off grid, and it's powered by solar, and there's a wind turbine on top of it and a battery, and we have installed a number of them, and we collect the data associated with them. I talked about the phaser measurement units, and number of other sensors that they communicate over our fiber network. And another thing that communicates over our fiber network is air quality sensors. It collects 5 different types of emissions, and we have installed these types of kiosks within the footprint so people can go and see the air quality within the footprint as granular as it can. And then the last thing is that this is the mural that is painted in behind this wall is a 2 megawatt battery for 4 hours. So what we have done is we brought students and artists within the footprint to come up with mural, and then we have developed an app that when you look at the mural and you go around it, it talks about the impact of climate change and how the energy sector and electricity sector can provide benefit and how we can work together to eliminate that. Another part of the things that we are doing is working with a lot of kids and students around the in different neighborhoods and in Chicago to expose them to possibilities that are out there. We ran a number of ideathon sessions, and the kids came up, we gave them a number of sensors and they programmed them. And we're working on patenting 2 of them and piloting them within the footprint for to capturing noise. And one of them is about identifying the population of rats in it's an issue in winter in Chicago. And another aspect of it is related to workforce that I'm not going to talk much about it. But just to wrap up what I talked about, our smart city work affects other industries. So it's not only about electric industries and electric sector and vice versa. We need each other to build smart cities with infrastructure and foundational programs to support education, health, equity, and advanced technology. Innovation is at the heart of smart city goals, which inspire a multitude of stakeholders to build better communities to benefit the people who live there. That's all I had, and I'd be happy to take questions from the audience. Emilio.
Okay, thank you, Shay, for your presentation. It was very interesting. And I have a question. I wrote my question in the chat, as you can see. And I was very interested about the microgrid, the Bronzeville microgrid, that I saw that includes also the IIT microgrid for the university. I don't know if you did some tests about the disconnection of the 2 microgrids, the one inside the other, I don't know. And because I know that also us here, we try to ask to this distributor to disconnect some parts of the network, but it is usually impossible to disconnect the load where people is connected. So we are in university. No, I see that you work in university as a joint professor. I see.
Yes, I am a professor at IIT.
Also, yes, and but to us it's very interesting to disconnect loads, but maybe if we have only virtual load, not true load, no, the people that is connected to the network. So it's very difficult to do some experiments. Also, if you try to justify these experiments, because we are doing this for resiliency tests, for instance.
To give you a bit of a background, we have been installing and testing a number of new technologies within Bronzeville. We treat it as a living laboratory, and as somebody who teaches at university, I value it a lot. But when we go through some of these testing, as somebody who's responsible for reliability metrics, working in a distribution utility, I hold my breath for like the duration of the test. And we have done testing twice on phase 1 of the project for the 2 microgrid. One is at IIT, as you said. The second one is on the medium voltage side, on the utility side. And we brought portable generators in case something went wrong. We we had solar and storage, and but what we didn't have at that time, at the phase 1 of the project, we didn't have dispatchable generation. And what we did during the testing was with solar plus storage for the duration of 8 hours and connected with IIT, at the point of interconnection, the power, P and Q, the active power and reactive power, we got it to 0. So it was, we didn't completely disconnected the switch because we didn't have the dispatchable generation to take care of the frequency and voltage within the footprint. We couldn't afford that. But the phase 1 of the project, we brought at the point of interconnection of disconnection with the microgrid with the utility, we brought the active and reactive power to 0. And we did number of testing of, if you go the power factor of 0.1 leading and lagging, how at the point of interconnection it looks like, what's the frequency and voltage within the footprint. The second phase of the project is the installation of dispatchable generation. So we went through an RFP, somebody else owns the gas units, and what we are going to do in February 2022 is to go through the full islanded testing of microgrid. That will be the plan. And yes, it's a risk that we take it as a utility, but we value the research and the fact that it helps with researchers and technologists how it works. So we accept the risk. We try to test it as much as we can, different scenarios in the lab to see how the system interacts. We have people from the field and from testing groups. So it's an army of people aligning to do, it might sound as a simple testing, but from a police department to people at ComEd, at control center, and setting up a war room close by to monitor the system impact, because people are connected to that footprint. So it's, I talked a lot to get to the point that yes, we have done this testing twice, and at the end of the project we are going to go on a complete islanding of these 2 microgrids and capture the data.
Okay, thank you, Shay. I don't know if from the floor there is any question. We have several students that this school is mainly for them. They are going to develop a project for a smart district, with considering also the electricity, but also the possibility of modify the buildings to include inside the buildings energy management systems, and like so. They are going to develop this project for smart district that we use an example for from my city, that is Cagliari in Sardinia. I don't know if you check where we are.
Yes, and it was one of the topics that I wanted to have touch on today. Is we would love to partner with you and share what we have learned. We have been doing some testing on connecting the integrating the building management system into our microgrid controller. So the microgrid controller at our control center, we can send command and control to the building at different types of events and see how it works. I would love to have a more dialogue with the team of students who are working on this project. And then one last thing is that I'm an engineer, and I love the technological aspect of the work. But when we are working on a smart district, which I did take a look at some of the work and publications that you have, is that we cannot forget the impact of people. It's not only about technology, it's the people within wherever district that you are developing this smart concept should feel the change that you have implemented. And that's the tricky part. It's the harder, I should say it's harder than the technical part.
I agree. I know there are any questions from the floor? Somebody want to ask something? Okay, seems there are no questions. So I wish you again happy Thanksgiving.
Thank you.
And thank you again for being with us here. And I will like to meet you again, maybe in person, in some place, or in Sardinia, or in Chicago, maybe, or in another place.
I look forward to meeting you in person.
Yeah.
Yeah. All right. Take care and be safe. Thanks for having me.
Thank you very much again, Shay. Bye bye. Grazie a tutti. Allora, anche per oggi mi sembra, diciamo, che gli incontri, diciamo, sono terminati. Quindi il prossimo incontro sarà per appunto domenica con, diciamo, un programma che appunto è molto interessante. E ci sarà appunto la giornata conclusiva di questa scuola. Quindi un saluto a tutti, anche da parte di Luigi, che purtroppo si è dovuto assentare per un altro impegno. E quindi ci vediamo di nuovo domenica pomeriggio. Arrivederci a tutti.